In the last example, we put all of the factors together. Now we're going to break them up. So the first thing we need to think about is, do these three terms have anything in common? Is there anything that we can bring out of all three of them? Well, 3 and negative 18 and 24, I could take 3 out of each one of those. X cubed, x squared, and x, they all have at least one x. So my greatest common factor that I'm going to pull out is 3x. So if I do that, I'm going to put in parentheses what's left over. So 3x cubed divided by 3x leaves me with just x squared. Negative 18x squared divided by 3x, I'm going to get negative 6x. And 24x divided by 3x leaves me with 8. Okay? So now we need to break up this. This looks a lot like what we did with quadratics, where we use that tic-tac-toe in order to factor that. At least for my class we did. So let's factor this. So what goes in the first box? Well, 1 goes there. Negative 6 goes here. And 8 goes here. So now I'm looking for two numbers that when I multiply them I get 8, and when I add them I get negative 6. Well, that happens to be negative 4 and negative 2. Because negative 4 times negative 2 gives me 8. Negative 4 plus negative 2 gives me negative 6. Well, what's the greatest common factor between 1 and negative 4? That's 1. Greatest common factor between 1 and negative 2 is 1. And then the last two boxes, those are our easy ones. 1 times what is negative 4? Well, that's negative 4. 1 times what is negative 2? That's negative 2. Remember, I always put my little x here, and then we're looking for the diagonals. So my two factors are x minus 2, or 1x minus 2 if you want to write the 1, and x minus 4. Okay? So now we're going to replace x squared minus 6x plus 8 with those two factors. Don't forget to bring down your 3x. X minus 2 and x minus 4. So now we've taken a polynomial that was written in standard form and we've written it into factored forms. These are the pieces that make up that polynomial. All right, so let's go on to our last thing. We're going to find the zeros for this polynomial function. And this is really easy. You should totally be able to do it. Remember from when we talked about quadratics that our zeros are where the graph meets that x-axis. So it's wherever our y value is 0. So if we want this times this times this to be 0, then one of them at least has to be equal to 0. So either x plus 1 is 0, or x minus 1 is 0, or x plus 3 is 0. So what we do to find the zeros is just set each one of those equal to 0. So if x plus 1 is 0, then what's x? If we subtract 1 from both sides, we find that x is negative 1. That's one of our zeros. Let's do the same thing with the second one. X minus 1 is 0. We want to get the x by itself, we add 1 to both sides, and we get x is 1. Do the same thing with the third term. X plus 3 is 0. How do we get x by itself? We subtract 3 from both sides. X equals negative 3. So these are our 3 zeros. So we found the zeros of it. Now they want us to graph it. Okay, so let's plug in what we know so far. We know that where x is negative 1, here's where x is negative 1, we have a point right there. We have a 0. Where x is 1, we have a 0. So we have a point right there. and where x is -3. We have a 0. So we have a couple points on our graph, but we need some more. So let's plug in some information around there. Let's pick some other points. What about -4, -2, 0, and 2? Okay, so I'm going to make this little chart of x's and y's. And I want to know -4, -2, 0, and 2. So the first thing I'm going to do is I'm going to plug in x is -4 up here. So if I do that, I have -4 plus 1, which would give me -3. -4 minus 1 is -5. And -4 plus 3 is -1. Now I just have to multiply all these things together. -3 times -5 is 15, times -1 is -15. So when I put -4 in, I got out -15. Let's do the same thing with x equals -2. So if I do that, -2 plus 1 is -1. -2 minus 1 is -3. And -2 plus 3 is 1. So -1 times -3 is +3. Positive 3 times 1 is +3. I put in a -2. I got out 3. Let's do the same thing for x equals 0. If you already know what you're doing, you can go ahead and fast forward, get through this problem, and then we'll go to the next thing. So 0 plus 1 is 1, 0 minus 1 is -1, and 0 plus 3 is 3. 1 times -1 is -1, times 3 is -3. So when I put in a 0, I got out a -3. Do the last thing for 2. When x is 2, 2 plus 1 is 3, 2 minus 1 is 1, and 2 plus 3 is 5. So 3 times 1 is 3, 3 times 5 is 15. And now we just graph these points. So when x was -4, y is -15. It's somewhere way down here, right? When x was -2, y was 3. When x is 0, y is -3. And when x is 2, y is 15. Somewhere way beyond where Miss Harmeyer can reach. All right, and now we just connect our dots. And remember, this is a curve, so they're not sharp edges. You can put arrows at the edges of your graph if you want, indicating that they'll keep going. All right. So let's do a quick check. Let's make sure that you understand what's going on. What I would like you to do is go ahead, try this problem on your own, and then come back, pause the video, and then come back to check your answer to see if you did it right. If you need to, look back at the problems that we already did. All right, so we found our zeros before. Remember, that's where our graph crosses the x-axis. But can we find the polynomial if they just give us the zeros? Sure we can. So if they tell us that we have a polynomial that has zeros at 2, -3, and 0, we know that x equals 2, x equals -3, and x equals 0. Now we need the right-hand side of this to be 0. So how are we going to do that? We're going to subtract 2 in this case. So we get x minus 2 equals 0. We add 3 in this case. So we get x plus 3 equals 0. And we don't have to do anything to this one. It's just x equals 0. Well, these are our factors. We just combine those, and that'll give us our polynomial. So we get x minus 2 times x plus 3 times x. I'm just going to put the x out front. All right, well, what form do they want it in? They want it in standard form. That means that we need to get rid of these parentheses. So let's FOIL the last two. X times x is x squared. X times 3 is 3x. Negative 2 times x is negative 2x. And negative 2 times 3 is negative 6. We can combine some like terms here. So this x is multiplied by x squared. 3x minus 2x is just 1x. And minus 6. And now share the x with each of these terms. X cubed plus x squared minus 6. There's our polynomial written in standard form that has zeros at 2, negative 3, and 0. All right, I'm going to give you a chance to do the quick check on your own. I want you to come back and check in to make sure your answer was correct.